Hello everyone. In this video we will learn how to name acids, hydrates, and we will do a mixed review of writing formulas. We will start by learning how to name ionic compounds that contain polyatomic ions. Polyatomic ions, it's a group of elements binded together with covalent bond and they have a charge. This table you have to memorize it. This is for memory, because we will write later on a lot of chemical formulas containing polyatomic ions. We will start with polyatomic ions that are mostly made of, that they have -1 charge. We will start by this set: perbromate, bromate, bromide, hypobromite. If we have to take a close look, the naming, it comes from the number of oxygen. As you see going down, number of oxygen decreases. When it is bromine, in this case, connected to 4 oxygen, this is perbromate. Then -1 oxygen, it will be bromate only. Then another decrease in oxygen to be 2 oxygens, it will be bromide. And then hypobromite with 1 oxygen. Using the same analogy, we will name the polyatomic ions that contain chlorine and iodine. This will be perchlorate, ClO4 minus, chlorate, ClO3 minus, chlorite, ClO2 minus, and with 1 O it will be hypochlorite. Similarly for iodine, of the one that contains 4 oxygen, it's periodate, 3 oxygen iodate, 2 oxygen iodide, and 1 oxygen hypoiodide. Another examples for polyatomic ions with -1 nitrate and nitrite. Also, if you want to take a close look, you will see that the one that ends with the suffix -ate has more oxygen than the one that ends with suffix -ite. Another example: hydroxide, OH minus, cyanide, Cn minus, acetate, C2H3O2 minus, permanganate, MnO4 minus, bicarbonate, HCO3 minus. There are polyatomic ions with -2 charge. Examples: carbonate, sulfate, carbonate, CO3 2 minus, sulfate, SO4 2 minus, sulfite, SO3 2 minus, chromate, CrO4 2 minus, dichromate, Cr2O7 2 minus, oxalate, C2O4 2 minus. Polyatomic ions with -3 charge, like phosphate, PO4 3 minus, phosphite, PO3 3 minus, arsenate, ASO4 -3. And the only polyatomic ion that has a positive charge, it's ammonium ion, which is NH4 + 1. So this table, we have to memorize it. Now let us practice. Write the formula from the names of the following ionic compounds. We have to recall that when I want to name ionic compounds, I only name them by their names. No di, tri, no prefixes. We give just the element its name. Sodium and sulfite, so this simply sodium and a sodium, SO3 sulfite, sodium sulfite. Sr, strontium, so this is strontium, and NO3 nitrates, strontium nitrate. Be stands for beryllium, and PO4 3 minus, as we said, is phosphate, so beryllium phosphate. NH4 stands for ammonium, F minus for fluoride, so this is ammonium fluoride. Cesium acetate, now he gave me the name and we want to write the formula. Cesium is Cs, acetate, C2H3O2 minus, crisscross, ratio 1:1. So cesium, H2, C3O2. Barium perchlorate, the perchlorate, ClO4 minus, barium is 2 plus, ClO4 minus, crisscross, and it will be barium chlorate. Ammonium cyanide, ammonium NH4 plus, cyanide Cn minus, criss-cross ratio 1:1, NH4Cn. Aluminium hydroxide, aluminium 3 plus, hydroxide OH minus, criss-cross, and aluminium, and all the hydroxide with subscript 3. Now let us write and name formulas of ionic compounds that contain transition metals. Transition metals are those metals that we can find them between column 2 and column 13. So from column 3 to column 12, these we call them transition metals. Transition metals. Transition metals, they have properties like normal metals, so they are malleable, ductile, conduct heat, conduct electricity, tend to lose electrons, but they have also other properties, like we can find the one ion in more than charge state. Like for example, copper, we can find it Cu plus and Cu2 plus. So this is copper 1. Also we call it cuprous. And this is copper 2. Also we call it cupric. Similarly for iron, it can be Fe2 plus, which is iron 2, or ferrous, Fe3 plus, iron 3, or ferric. So the metals, the elements, transition metals, they can exhibit more than one oxidation number. Also, another property for transition metals is that they can be used as a catalyst. Because they can exhibit more than one oxidation number, so we have to write them. When we want to write their names, we have to indicate their charge in a Roman number. Let us see how. Number 1, Mn2s. Mn2s, it came from, because it's iron, from the criss-cross, sulfur from group 6, 2 minus. They gain 2 electrons to reach stability. So for the ratio to be 2:1, it means that this should have been +1. So this is manganese, and we indicate it's a charge 1, and sulfide. Nickel oxygen group 6, so 2 minus. For the ratio to be 1:1, this should have been 2 plus. For the ratio to be 1:1, so this will be named as nickel 2, Roman number 2, oxide. Chromium nitride, for the ratio to be 3:2, nitrogen group 5, which means it has charge 3 minus, because it gains 3 electrons to reach stability. So for the ratio to be 3:2, chromium should be +2 because of the criss-cross issue. So this I name it chromium 2 and nitride. CuF2, chlorine group 7, it has a charge -1, and for the ratio to be 1:2, so the charge here should be +2 because of the criss-cross later on. So this is copper, Roman number 2, and fluoride. PbCl, Cl group 7, -1. So for the ratio to be 1:1, this should be +1. So this is lead 1 chloride. Tin 2 phosphide. Tin is symbolized by Sn2. It means that charge 2 plus. Phosphide comes from phosphorus, group 5. It has charge 3 minus. Criss-cross, the formula will be Sn3P2. Molybdenum 3 bromide. Molybdenum MO 3, it means that charge 3 plus, and bromide group 7 Br minus. Crisscross, it will be MO Br3. Titanium 4 oxide. Titanium is 4 plus. Oxide, oxygen from group 6. It can gain 2 electrons to reach stability. So it will be by crisscross Ti2O4. But we have to always write the formula in the simplest form. As long as the two numbers divisible by a certain number, they are divisible by 2. So the final formula TiO2. Vanadium selenide. Vanadium 2 plus. Selenide, selenium is group 6, so 2 minus. Ratio 1 to 1, so vanadium selenide. Cadmium 1. Cadmium plus. Sulfate is a polyatomic ion, 2 minus. Crisscross, so Cd2SO4. Now we want to talk about acids. An acid starts with hydrogen and ends with a nonmetal or polyatomic ion. General rules for acids. The first one, binary acids. They are acids made from hydrogen plus a single element like HBr. So H hydro, and because acid we use the suffix IC. So hydrobromic acid. We have another type of acids, oxyacids. Acids made from hydrogen plus an oxygen containing polyatomic ion like HBrO3. BrO3, it's a bromate, so simply it is a bromic acid. Br2O minus, it is a bromide with H, it will be acid, we call it bromous acid. Let us name and write formulas of the following acids. HCl, we call it hydrochloric acid. HI, we call it hydroiodic acid. H2SO3, this is sulfurous acid. HNO3, this is nitric acid. Phosphorus acid is H3PO3. Hydrofluoric acid, HF. Perchloric acid, HClO4. And acetic acid, HC2H3O2. Now let us move and talk about hydrates. What are hydrates? Hydrates are ionic compounds that have a specific number of water molecules attached to them. On the other hand, anhydrates are hydrates that have had the water removed, for example, like heating. The number of water is indicated with a coefficient in the formula and a prefix in the name. Examples of hydrate, this one. So what is hydrate again? It's any salt that has water chemically bonded to the ions in the crystal. Structure is a hydrate or hydrated crystal. Look at this copper sulfate. It is a hydrate and it has a deep blue color. Another example of hydrate, cobalt chloride, 0.6 molecules of water. This is pink. If we heat up this cobalt chloride, 0.6 molecules of water, it will turn into blue, which is cobalt chloride without the molecules of water, and we call it in this way anhydrous. Now, how we name them? We name the compound as it is, and before the water molecule, we use the numbers di, tri, phosphorus, penta, etc. Let us see how. MgBr2, it's magnesium bromide. How many molecules of water? 2, so dihydrate. This is cobalt chloride. Cobalt, I have to write for it its Roman number. So cobalt chloride, it's cobalt 2 chloride. How many molecules of water? 6. So hexahydrate. NaNO3. So this is sodium nitrate with 5 molecules of water. So pentahydrate. So this is sodium nitrate. Pentahydrate. Ammonium and with chloride. So this is ammonium chloride. 3 molecules of water, so trihydrate. Now the name is given to me. Let me write the formula. Potassium sulfide, potassium is plus, sulfide 2 minus, crisscross K2S, so K2S, and tetrahydrate, it means dot 4 molecules of water. Lithium hydroxide, lithium plus and hydroxide polyatomic ion minus, ratio 1:1, so lithium hydroxide. Monohydrate, it means 1 molecule of water. Calcium sulfide, calcium group 2, 2 plus, sulfide from sulfur, group 6, 2 minus, ratio 1:1 because same charge, so calcium sulfide. And octahydrate, it means it contains 8 molecules of water. Barium chloride, barium group 2, which is 2 plus, chloride Cl minus, crisscross, it will be BaCl2. And heptahydrate, it means that hepta means 7, so it contains 7 molecules of water. So barium chloride, 7 molecules of water. Now we spoke about acids, hydrates, and how we name them. Let us make a mixed review of molecular, ionic, and acid compounds. So we will start. We have aluminium arsenide. Aluminium is from group 3, so 3 plus, arsenide group 5, so 3 minus, same charge, so ratio 1:1, so aluminium arsenide. Permanganic acid is HMnO4. Tin 2 sulfide, tin is 2 plus, sulfide SO3 polyatomic ion 2 minus, charge the same, so ratio 1:1, so SnSO3. Vanadium 5 fluoride, vanadium 5, it means 5 plus, fluoride group 7, so -1, crisscross, it will be VF5. Lithium acetate, lithium group 1 plus, acetate is a polyatomic ion, C2H3O2 minus, same charge, so ratio 1:1, and lithium acetate. Hexaboron monosilicide, this is molecule because we see the prefixes hexa and mono. So hexaboron, boron 6, mono, so 1, silicide comes from silicon. Hydrofluoric acid, ammonium nitrate NH4 plus and nitrate NO3 minus, ratio 1:1, so NH4 NO3. Silver cyanide, silver Ag plus, cyanide Cn minus, ratio 1:1, AgCN. Copper 2 chloride, so copper has a charge 2 plus, chloride Cl minus, crisscross CuCl2. Phosphorus triiodide, so 3 iodine. Potassium fluoride, K plus, fluoride group 7, ratio 1:1, KF. Hypobromous acid, so it is, as we learned earlier, HBrO, hypobromous. Nitric acid, it's HNO3, Acetic acid is HC2H3O2. Phosphoric acid is H3PO4. Chlorine dioxide, so Cl and 2 oxygen. Periodic acid, HiO4. Potassium permanganate, potassium is K plus, permanganate MnO4 minus, so ratio 1:1, KMnO4. Chromium 6, so we have chromium 6 plus 6, and cyanide, polyatomic ion -1, so the ratio it will be 1:6, so chromium and all the cyanide 6. Sulfuric acid, H2SO4. Perchloric acid, HClO4. Vanadium 3 plus, selenide from selenium group 6, Se2 minus, so ratio will be 2:3, so it will be V2Se